So now we're going to shift gears just a little bit into perspectives on analysis as a service. I actually think Eric provided some great foreshadowing on that topic as one of the threads in his talk. And also some explorations of non-traditional GEOINT. We're going to do this from both public sector and private sector perspectives. So I'd like to start with someone who began his career in the national lab space at Los Alamos. He's actually going to be talking about some technology that emerged first from Los Alamos that he and his business associates have brought into the private sector. In a company named Descartes Labs. He is co-founder and chief science advisor of Descartes Labs. Please give a round of applause to Dr. Stephen Crumby.
Okay, the sad fact of most of imagery analysis is that actually nobody really wants pixels, they want answers. So what I'm going to be talking about is a view of the future of what analysts should be able to exploit. And we're going to motivate it with some examples of recent work that we're doing, taking technology originally incubated at a national lab and now being applied today in support of Wall Street. So as we all know, there are now way too many pixels for humans to look at. As we look at the world, and in this case what we're showing actually is a time-lapse video of the United States, with something like 500 million pixels per frame. We've got the ability to collect a vast amount of data, historically from coarser spatial resolution sensors like Landsat, but now all the way down to 3 meters per pixel daily from Planet, and well below 1 meter per pixel from Digital Globe, and all the future systems like Black Sky and other things that are coming down the road, let alone the aerial systems that we've just heard about. So there's way too much data for people to look at. But the pixels are not an answer. Okay, so I'm going to describe how we get to a particular answer to a particular real-world problem and give you a sense of what we had to do to the data to get there. Okay. Now, back up one, please. This is the video. Thank you. So one of the sort of classic textbook problems of remote sensing is vegetative health, which the commercial version of that is agricultural monitoring, and then in particular the valuable version of it is agricultural forecasting. The state of the art for this is it's really only done in the United States. It's based on two products produced by US government. One is the US Geological Survey's National Land Cover Dataset, NLCD, that's made from Landsat data and produced on a time step of every 5 years. This is the base map of the United States. And then the USDA adds something called the Cropscape Data Layer on an annual basis. It maps out where the actual agriculture is and names it. The issue with these two techniques, if there is an issue, it's that the update is actually slower than it could be because the satellite imagery comes in on a daily basis. So why is the NLCD made every 5 years? Why is the CDL only released at the end of the year? Partly it's technology, partly it's a workflow issue, partly it's just not yet taking advantage of the full capability that's available in commercial cloud. And I think, well, especially the folks in this room, we understand. We are at the moment of a revolution in geospatial analysis brought about by three things. The availability of data, like I just showed in the previous video, across the spectrum and spatial ranges and temporal ranges. The fact that there's effectively supercomputing available in commercial cloud for pennies on the dollar compared to traditional supercomputing. And the fact that we've now got the algorithms to do something with all that data, with all that hardware. So okay, so this is what people have made in the past. What we've done is basically automate the process of producing these maps so that we can drive our own high-level geospatial business intelligence products. So here's an example of generating an updated NLCD. So the last NLCD official release was in 2011. The last one should have come out in 2016. As far as I'm aware, it hasn't been released as yet. But using the machine learning, we can leverage the human-made maps to produce new maps, right? And not be dependent upon a sort of old-fashioned, mostly manual analysis process, but use the machine learning to generate additional maps to fill in the years and go forward in time and with the latest imagery and produce timely maps. Now, there's a legitimate question as to how well do machine-generated maps compare to human-generated maps. But that's a question that's amenable to analysis, okay? And I think that more and more, future task of analysts will be to assess and clean up or finish maps that are 95, 99% complete when they come out of the algorithm. Okay, so we can make our own broad land cover maps. If we zoom in, we've been teaching our computer to use time sequences of higher resolution imagery to learn where the field boundaries are. So this is a segmentation of the terrain based on functional use of the ground, what crops are being grown where. And beyond that, we can actually identify specific crops. So here was our forecast made during the 2015 growing season. Corn is yellow, soybean is dark green. It's a patch of Iowa somewhere. And we're learning specific crops based on spectral signature from the time series of satellite observations. And we can compare this to the manual map made by the USDA. And we can see that we're getting better than 90% label agreement, which is about the level of accuracy of the human-made maps. Okay? But you can go a step further too. So now let's zoom out, let's look at the whole country. Here's our version of CDL made in August of the growing season as opposed to being released in February the following year, which is when the USDA releases its maps. So we have this map, but we want to not just say where is the corn and where is the soy, but how much is being produced. And so because my team and I are a bunch of escapees from a national lab and we've got this science background as well as computer science background, we were actually able to develop statistical models that used the time series of the spectral observations to infer the actual yield. And here we're showing it per county. And because it's software, it's easy to apply over the past decade or more of satellite imagery and build up interesting statistics of this is what the trend is like, this is how the extent of the crops is changing through time. And in this case, we were able to, in 2015, forecast where production would be up or down relative to the previous year's production. 2014 was a very good year. 2015 was actually a good year, but not as good as 2014. And this is closer to an answer, but the real answer that people actually wanted is actually just basically time series. Take all the pixels from all the satellites and boil it down into a time sequence that you can send somebody in an Excel spreadsheet or a CSV plain text file. So what we're looking at here on the left is an error analysis that shows the black line, the step function that you can see is the error in the human field campaign that USDA runs every year, where they send people out to go pick ears of corn and estimate how much production is going to come out from across the country. And it's interesting that just using publicly available NASA imagery, NASA USGS imagery, trained using USGS and USDA ground truth, the red line shows that all the way through the growing season, the machine learning with satellite imagery was faster and more accurate than the ground sampling approach. And the ground sampling approach is very expensive and labor intensive and doesn't really scale to the rest of the world. So this is potentially a much cheaper, scalable approach that can be applied to many other countries, as I'll show in a sec. The right-hand panel shows the forecasts per year, and you can see them changing through time. By the way, most of the error at the beginning of the growing season is just due to weather that hasn't yet happened. Okay, so it's a very understandable physical reason for the error. In particular, if we look at the right-hand panel, we can see, look at the yellow line at the bottom of that graph. That's the 2012 growing season, which was bad in the United States. Notice that very early in the growing season, we could tell there was a historically bad production year. Okay, and that's important in a second. So, being able to produce a time series in an Excel spreadsheet that we can email to our customers on Wall Street or at the CME in Chicago, that's generating a high-level, automated business intelligence product, geospatial business intelligence product, and delivering it on a daily basis. And I think that that's the sort of high-level product that most people want. They don't want to have to dig through the pixels, and they certainly don't want to have to look at the pixels. So where are we going next? The methodology scales to other countries, so to the whole world, in fact. So here's the best available sort of science community land cover map of the world, the ESA glob cover. And again, this is derived from satellite imagery, so let's take all the Landsat data ever collected and all the Sentinel-2 infrared imagery ever collected, including red edge bands that weren't available in Landsat. And let's take all the Sentinel-1 SAR imagery and realize Sentinel-1, Sentinel-2, Sentinel-3, the data is free. Landsat's free as well, but all the Sentinel data is free, and it's going to be free going forward. And this is a remarkable time where data that previously was commercial grade data, proprietary data, is now just available for free everywhere. And if you have the right tools, you can exploit it. So with all of that data, we're in the position to start to make our own base maps again and then start to do forecasting. And this is a storyboard sketch of a web app that we're currently developing thanks to we have an announced project with DARPA where we're developing a global food production early warning system that can hopefully use satellite imagery to predict food production problems across the Middle East and North Africa, just using the publicly available data so that you can share it with everybody, okay, and give warning to folks. Okay, so that's an example of a high-level business intelligence product with sort of a monitoring flavor. The next step that we're going to is something that we call geovisual search, where the idea is that you should be able to have interactive feedback with the human analyst, so that wherever you are in looking at the world, if you interact with that map, the computer should be able to figure out what it is you liked about that spot you interacted with, and they'll go find you all the others. So here's an example of finding all of the football fields. Okay, and the upper left-hand panel is a representation of 1,000 of these football fields that were found. The sort of grid of cells is showing you individual tiles that have been detected. And think about this, okay? Descartes Labs is a tiny company still. We're 35 people spun out of Los Alamos National Lab only just 2.5 years ago, with some generous VC support and building on the legacy of all the technology and all the training that the team had at Los Alamos before we went out into before we ran away to join a circus. In just a couple of years, we've built this ability to use commercial cloud, so effectively supercomputing in the cloud, to take many sources of satellite imagery, break them up into tiles, run deep learning on all of that satellite imagery, update this whole thing every night, and be able to launch interactive search demos. This search.descarteslabs.com is a tech demonstration that's available. All of you actually could look at it basically right now on your smartphone, where on a time scale of seconds, if you touch somewhere on the screen, the computer will automatically find you everything that looks like the thing you touched, okay? And now imagine the next step, which is where this is going. The next step is that all of these sites that you've found and that the human now has the opportunity to confirm, all of these sites could be monitored. All the interesting anomalies could be flagged. This thing is essentially a persistent query that's now being run against global scale satellite data. And all of the thing that we're showing is real and is being done with commercial cloud, commercial sources, and public sources of imagery using algorithms where in many cases the large companies developing the algorithms are releasing them all open source. So we're in a technology field that's poised for major continuing change as we go from space to aerial, like the previous speaker spoke about, all the way down to IoT and the ground. Okay, so space to mud is coming. And when this is married up with cyber and everything else as well, we're really at the edge of global situational awareness. Thank you.
Excellent. Great job. Thanks so much. Wonderful. Excellent. Thanks, Stephen. So we just finished with a public sector guy who went private sector. Next, we're going to go to a public sector perspective. The most important thing you need to know about this individual is that he married extremely well. His wife's just a delight. He works inside under the director of plans. New director of plans is Dr. Anthony Vinci. If he's not here, you should find him out on the circuit. Great guy to meet. Our next speaker is the director of the Office of Strategic Operations. It's kind of the strategic planning element inside the DP. Please give a hand to David Gauthier. All right, do it.
Okay, thank you very much for having me here. And I'm going to talk about analysis as a service. And I'm going to start with why it's so important to the future of NGA and our strategy. So with that, I have to talk a little bit about our strategy. Every organization needs services and expertise to carry out its mission. And the axes on the chart behind me talk a little bit about, in general, how much energy or resources you must apply to create services or expertise against your mission. And so if you're applying an enormous amount of resources, you're likely the inventor. And that's what the right-hand side says. If you're able to actually harness and buy capabilities that someone else has already invented, you're brokering those things. And if you're able to use something because you're sharing amongst your partners for free, then you're actually managing a free capability. So I like to think of three ways we can access capabilities. We can either build it, buy them, or share them. And in the beginning of GEOINT, there was not an incentive for anyone but a government to really marshal the resources necessary to do imagery and mapping at scale. And so this is what our past represents. The fact that we were building it, we were inventing these capabilities. Transition to today, and there's this rise of decades of investment in what I'll call the space investment writ large. And then there's also been a rise of internet and web services and ubiquity of data and smart devices that's really caused an explosion of capabilities in the commercial market. And so that explosion of capabilities is the revolution coming to get us. And what we need to do is harness this revolution more now than ever before. Now, at smaller scale, I'm showing NGA has been able to work with its partners and manage capabilities across the NSG and the ASG in order to get a little bit of capability in that sharing section of the chart. We've also been able to broker commercial imagery to a large number of people across the community. So we've been doing some of that brokering, but our building needs to change, and it's not enough. And so really our future is we have to stretch the fabric of the discipline, and we have to pull ourselves up and continuously invent, innovate, so that we can truly differentiate what we're inventing and building on the government side, and then we can harness a greater capability of services in the market to broker to meet, so that supply can meet demand across thousands of people supplying services, and then also do a much better job at managing and leading the NSG and ASG so that we can truly enable to lift all partners with shared capabilities. And so this is what our future looks like, and we have to grow not only our differentiated capabilities, but everything else. So what used to be mostly build it, somewhat buy it, somewhat share it, is transforming us to lead, broker, and differentiate in the world. Why is this important to analysis as a service? Well, the center of this graphic talks completely about brokering services, and all of those services that are available in this golden age of GEOINT need to be brokered across the community, the global enterprise. And so one of the best services we have is analysis as a service. What is that? In the beginning, when we started to approach analysis as a service at NGA, we really did think of it too narrow. We thought of it as analytic product that we had been used to creating for the past 20 years. And so we went out to purchase that product. What we learned along the way is that it was much more of a rich collaboration with the companies providing services to look at the data that they were accessing, the observations they could create, and the products that they could produce. And we also learned that we had to partner a lot more closely with them analytically in order to get a high return on investment. Also, analysis as a service to us could be as much as a web analytics platform that's hosted by somebody else that accesses our data and provides services back to us. Now, I'm going to jump ahead a little bit here and talk about why we care about analysis as a service. I see 4 main benefits to this. One is, if you don't have to invent the capabilities yourself, you don't have to outlay a large amount of tech capital for technical development, then it's less cost than inventing the infrastructure yourself. That's obvious. Another one is we get access to more non-traditional GEOINT sources. So there's an explosion of GEOINT sources in the world today. We heard from space to mud, and those are all on the table to creating new services. And with that requires more innovative analytic techniques. We've heard a lot about machine learning, deep learning, AI. Those techniques are all able to, for very specific problems, like the gentleman from Georgia Tech said, problem solved. You know, we can solve those specific problems, and those services are available in the market now. And then finally, all of that means there's more time for generating insights, where we can bring the human mind to the data, we can bring the human mind to the analytics, and generate deeper insights for our customers. So what have we done in this space? There's been a slow start to approaching analysis as a service in the commercial market. It started, from what I can tell, 2.5 years ago when my group contracted for the first proof of concept. And that was with a small business out of Ohio called ITC. And their job was running analytics on large data for hedge fund companies. And so we worked with them to run analytics on large data accumulated from the internet collection capabilities that they had, to look at foreign investments in Africa and help us understand in more detail what foreign investments had been happening in Africa and what the predictions were for future investment. And that went fairly well, but we learned a couple of key points from that experience. One was, know exactly what the company's capabilities are, because we made assumptions the company could do more than they were able to do. And to highlight some of that, the second point of learning is that we realized we had to have our analytic expertise embedded from the beginning and to work together in a teamed approach. So that brought us to our second proof of concept, which was an RFP in June 2016 that led to the Tundra contract. The Tundra contract was at a larger scale and brought us a company called Wiser. And Wiser was able to look at several problems from the analytic domain, and one of which was counting rail cars, which I'll show you here. And so over time, their system became much better at counting rail cars off commercial imagery. And now they're beginning to identify the type of rail car. And we're working with them to structure those observations very specifically so they can be ingested into our systems, and we can have rail cars as a service as one of the solved problems in our domain. They're also working on several other analytic problems, and this work wraps up in October of this year. But then something else interesting happened, and I call it a market disruptor. We actually weren't anticipating such a bold move so quickly, and it came from a company called Vencor. Vencor actually created a multi-layered approach to providing tailored analysis across a lot of non-traditional GEOINT sources. And it was at first tracking the cessation of hostilities in Syria. And it did this fairly well in the open source realm, and so it got a lot of attention from the US government, and we began using this capability. And at the same time, Vencor also grew into new types of non-traditional sources of GEOINT, one of which was microtasking. It worked better than expected. And an example shown here is microtasking for human geography crowdsourcing in the neighborhoods of Aleppo, Syria. And what they were able to provide was a time series of analysis over which militant groups controlled which neighborhoods over time through this approach. And they combined this microtasking with other ways of acquiring information, again, from space to mud in the open market. So my takeaways for analysis as a service is that we've really just begun, but this is a wide open market where it's exploding with capacity and potential at the moment. And we really have three concerns for new services coming forward. And we ask your help to solve these problems. One is quality control. Quality control can mean simply we lack understanding of the veracity of the data, or it could be poor quality. And we need measures and rigors and controls for that, all the way to the worst case scenario that the data could be poisoned. Another issue we're going to deal with in analysis as a service is perception. From unconscious bias that may be inherent in somebody's approach to analysis, all the way to intentional bias that's designed to influence the user. And then the third real takeaway concern I have is incoherence. I've already called it an explosion of data and services. With that, it could just be an explosion of noise that then obscures the truth. And even worse than that, it could be an explosion in exactly the wrong way, where it turns down the gain on the real signal we're trying to find. And so, again, in summary, want to ask for your help as we produce new solutions, as we go out in the fall of this year with a larger set of requirements for analysis as a service, that we're looking for your machine learning and your algorithms and other sophisticated techniques to help combat these concerns that we have. Thank you.
So last, we're going to go with another gentleman who spent some time in the public sector and is now at Orbital Insight. He is their public sector, the head of product management for the public sector, Matthew Swastik. Let's give him a round.
So unfortunately, I came to a GEOINT conference and didn't bring any pretty pictures, which is probably a mistake on my part, but I'm going to talk to you about Orbital and what we do at Orbital Insight. So my name is Matt Swastik, Director of Product Management Public Sector, which means I focus on federal, state, local, NGO, and international customers, mainly in the public sector, so governments, et cetera. What do we do at Orbital Insight? We take computer vision and machine learning and data science, apply it to satellite imagery and other geospatial data at scale to understand what's going on in the world, to develop the economic pulse of the planet, and to look at the world in a different way. We want to see what a country does, what the globe does, where all the planes and all the cars and all the buildings and all the roads are. So what does that mean from a non-traditional GEOINT perspective? Non-traditional GEOINT users in my mind are not imagery analysts or imagery users or geospatial data users. They're the everyday person that just wants to get some actionable insight or some meaningful context. So how do we do that with imagery? Well, we want to extract the knowledge from imagery and deliver it in a way that's consumable and scaled and statistically normalized and statistically understood, but traceable back to all that source data. So at Orbital Insight, we focus on several sectors initially now: financial services, energy, insurance, public sector. And we're trying to work with those customers to understand fundamental things going on in the world. So one thing we've done recently is map poverty in Sri Lanka, and we're mapping poverty in Mexico for the World Bank, so they understand where the challenging areas are, where investments and interventions need to be made. In financial services, we have products like our retail or energy product that focus on telling you how Walmart is doing based on the cars in their parking lots. Same thing for Home Depot and other companies. In energy, which is a huge market for us and a huge product for us, we're trying to understand where all the oil in the world is. Now we're monitoring floating rooftop tanks and telling you what China's oil volumes are today based on today or yesterday's data. So we're providing transparency for people to action on and make decisions with. So in the case of GEOINT here, we see a lot of folks that I know are very familiar with imagery and geospatial data, That's why you're at GEOINT, the flagship conference, and I thank USGF for hosting this and inviting us to talk. But what we want to find out is all those users that want to understand what's going on in the world in a different way. How do we do that? So a confluence of events has happened in the last 6 years that has made what we're doing today possible. 3 main things. First is advances in computer vision and machine learning that you've heard a lot about today. So deep learning now has on par with human performance in certain use cases. It doesn't do everything, but it does some things very well. The second piece is ubiquitous cloud computing. So what does that mean? I can now log into Amazon and spin up a data center in minutes, versus having to invest months or years of investment to build one. And the third piece is the explosion of satellite imagery and data available in the world today. You've got traditional companies that are innovating. You've got new entrants to the market that are putting up satellites that nobody thought, one, they could put up, or B, would have imagery that could do something, all of which has led us to have the conversation where we say every pixel has its place and every pixel has value. So you have traditional US government providers like Landsat, USGIF, other sensors. You've got emerging market providers putting CubeSats up at incredibly low cost points. And you've got traditional providers with hugely well-developed archives of imagery and well-understood sensors. So these 3 things have come together, and at Orbital, we're trying to do this at scale. So we want to take a provider's entire archive of every image they've ever taken and every image they're ever going to take, fuse them together to deliver that actionable insight I talked about. So I was told I have 12 minutes, and as you can tell, I talk very quickly. What I'd like to talk about next, though, is kind of where this goes in the future and what analysis of a service is really going to mean for folks. It's not going to replace an analyst. The human mind is still going to provide that context or the meaning of the why something is happening. But if you're counting cars somewhere, or if you're calculating NDVI, or you're a photogrammetrist mensurating the level of something, many of those tasks can be automated. That doesn't mean they can be automated perfectly. There are errors in all these capabilities, but as we see the explosion of data, you can't possibly hire enough people to look at all the data. We did a back of the envelope calculation, and if every satellite that is scheduled to go into space by 2022 goes into space, you're going to need about 8 million people working full-time every day looking at pixels. I don't know about the audience here, but personally, I don't think that's necessarily affordable for any customer set. So that's why automation is so important, to free up the data wrangling, the mundane, everyday tasks that can be repeated, to understand what's going on in the world and deliver that data in a way that's just consumable by an analyst to say the why of something is happening and to action on that. So with that, I think I probably talked for about 3 minutes. I actually don't have anything else. That's the key part here. We're based in Mountain View, California. We've got about 60 people now. We've been around for 3 years. We're heavily focused on the engineering side of the house. We've got about 40, 45 engineers, PhDs in electrical engineering, statistics, biostatistics, physics, applied physics, computer engineering, computer science, all focused on doing what I said before, is taking imagery at scale and looking at the world in a different way. Thank you.